The focus of this section is on understanding common data visualizations, what they are designed to communicate, and how to read them critically. We will look at pie charts, bar graphs, histograms, scatter plots, and line charts. Each has a specific purpose. Misusing one often leads to incorrect interpretation. By the end, you should be able to look at a chart and quickly identify what it is telling you and what it is not. The goal is to build your judgment about which display to use, how to read it, and how to challenge visuals you see in meetings. Before interpreting any visual, pause and consider what your decision point is. Then check whether the chart data describes categories, such as departments or product lines, or quantities along a scale, such as hours or dollars. Next, consider whether you are looking at a single variable or some relationship between two. Finally, check whether time is or should be part of the story. For example, a trend across months. If a chart type does not match the data structure, your interpretation of it might be risky. These 4 questions guide you to the right chart and help you see quickly when a chart in front of you does not fit the decision you are trying to make. Pie charts are most useful when you want to show how a whole breaks into a small number of distinct parts. A rule of thumb is that if there are more than 5 categories, don't use a pie chart at all. Some businesses cap this at 4 categories. Each slice represents a category share, and all slices together must add to 100% for the chart to be meaningful. They help people grasp the general balance between categories. But they are weak when you need to compare similar slices, because humans cannot judge angles very accurately. Moreover, one overwhelming category can hide more relevant information about differences in the smaller categories visually. If a business decision depends on telling whether one category is slightly larger than another, a pie chart turns that into guesswork. Pie charts should be used for proportional awareness only. In the task's completion example, using the grouped frequencies gives us a better pie chart visual. Bar graphs are designed for comparing categories such as regions, products, or survey answers. Bar graphs work better for qualitative variables or discrete quantitative categories. Each bar represents one category from your sample, and its length or height shows how big that category is. People are naturally better at comparing lengths than angles, which is why bar graphs support more precise business judgment than pie charts when ranking matters. When reading a bar graph, always check whether the vertical axis starts at 0, because a cut axis can exaggerate small differences. Also, note whether the bars show raw counts or percentages, since that affects how you talk about scale and impact in decisions. In the tasks example, we use the raw values of hours taken to create either a horizontal bar graph or a vertical column graph. With discrete or qualitative data that represent categories, you always want to set the bar high. A histogram looks like a column graph, but instead of separate categories, it groups numeric values into continuous intervals. The bars represent intervals of values, not separate categories. Since the data flows across the scale, the bars touch each other in a histogram. When you interpret a histogram, you are asking how the data are distributed across the scale, not which named category is bigger. Look for where values cluster, how wide the spread is, whether the pattern is symmetric or skewed, and whether there are isolated bars that may indicate outliers. Remember that the interval size affects the visual, so you should read the overall pattern rather than reacting to every small rise or dip. In the task example, the bins 0 to 2, 2 to 4, and 4 to 6 are presented as if they were continuous data, and not discrete. If you carefully compare this with the earlier pie chart, you will see that now there are 11 tasks in the first category, 6 in the second one, and 3 in the last one, instead of the 10, 7, and 3. This is because the task taking 2 hours now gets included in the first bin. With continuous quantitative data, the history must be captured in the histogram. Bar graphs and histograms often get confused because they both use rectangular bars, yet they answer very different questions. Use a bar graph when you have distinct groups, for example, marketing, operations, and finance, and you want to compare their sizes or percentages. Use a histogram when you have one quantitative variable measured on a scale, such as number of hours per task for a sample of work items, and you want to see how those values are distributed. If you try to use a histogram to compare departments, or a bar graph to show the shape of a continuous distribution, the visual will not match the underlying data structure, and interpretation quickly becomes misleading. Scatter plots are useful when you want to understand how two quantitative variables are associated with each other. Each dot represents one observation in the sample, pairing values such as age and weight, or any other related measures. When you read a scatter plot, first look for the direction of the pattern. Do higher values of one variable tend to align with higher values of the other, or with lower values? Next, observe how tightly the points cluster around an imagined line or curve, which reflects the strength of the association. Pay attention to outliers that sit far from the main cloud, as they may represent special cases that deserve separate investigation. And always remember that seeing an association does not prove that one variable causes the other. While we cannot predict if two highly associated variables have a causal relationship with each other, it is almost always true that variables that have a causal relationship with each other are associated with each other. Line charts make sense when time is naturally ordered along the horizontal axis, and you want to see how a metric evolves. For example, monthly inflation rates from January 2021 to May 2022 can be plotted as points and then connected by a line to show the time series. The line helps you spot gradual trends, recurring patterns, or sudden changes across the period. These can highlight cycles or seasonality, and more importantly, identify sudden structural breaks. However, if your data are random pairs without meaningful order, such as age and weight across teenagers, forcing a line through those points creates an artificial path that suggests a sequence that does not exist. In that case, stick with a scatter plot and keep the interpretation focused on the relationship, not on a false sense of progression. Moreover, always inspect a vertical axis scale. A compressed or exaggerated scale can make small changes appear dramatic. Whenever you see a chart representing data pertinent to your business, your first responsibility as a decision maker is to confirm that the visual matches the underlying data and the business question. Check that categorical data are not being forced into a histogram, and that time-based patterns are shown with an appropriate time series chart rather than a random line. Look closely at axis scales to ensure they do not exaggerate or hide variation. You might have noticed that heat maps are not separately covered in this video. That is because they do not add any statistical meaning or clarity over cross tabulations that we covered earlier for qualitative data. They only add color coding to highlight the hot spots. However, depending on whether they represent raw counts, row percentages, column percentages, or total percentages, the results can look drastically different. A critical eye and skepticism when interpreting a heat map are crucial. Finally, remember that patterns on a chart can indicate useful associations, but they do not by themselves prove why those patterns exist. Keeping that discipline prevents overreaction and helps you ask better follow-up questions before committing resources toward testing hypotheses and drawing conclusions. As we have discussed in this video, different chart types are suited to different purposes, from showing shares of a whole to exploring relationships or tracking change over time. When you next open a slide or dashboard, start by asking whether the chosen visualization fits the data and the decision at hand. Pay attention to scales, axes, and labels so that you interpret magnitude and risk correctly. Most importantly, treat each chart as the beginning of a conversation, not the final word, and use it to guide questions about patterns, trade-offs, and practical actions for your organization. Remember that when you choose the wrong chart, you might get the answer to the wrong question. And whatever decision you make based on that answer is likely to impact your business outcomes.